Good evening, everyone. Dr. Karthik sir, good evening, sir.
Hi, good evening. Can you able to hear me?
Yes, sir, it's audible.
Okay.
Kindly share your screen, sir.
Yeah, sure.
Yes, sir, it's visible.
Yeah.
Sir, we will wait for another 2 minutes and we will start, sir.
Okay, sure.
Thank you. So, good evening, everyone. I welcome you all to the fifth day of 6-day FDP on recent advancements in material, manufacturing, and technology, organized by the Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, West Godavari District, Andhra Pradesh. And today we have the first session, and I would like to welcome our today's first session resource speaker, Dr. K. Karthik, Assistant Manager, OLA Electric Technologies Private Limited, Bangalore. And before getting into moving on to the today's session, let me first introduce today's resource speaker, Dr. K. Karthik. And I'm happy to introduce Dr. K. Karthik, Assistant Manager, Ola Electrics Private Limited, Bangalore. Sir has completed his post-graduation in Master of Science in Physics from Annamalai University, Chidambaram, and he completed his Doctor of Philosophy in Physics from Pondicherry University under the thesis Lithium Garnet Dispersed Freestanding Polymer Composite, Electrolyte Membrane for Lithium Metal Batteries. Sir having academic credit, he is qualified for NET eligibility test in 2012 and having lifetime member of Energy Science Society of India from 2015 onwards. He is also having National Research Fellowship CSIR UGC JR from 14 to 16. Also CAR UGC SRF from 2016 to 2019. Sir having professional academic experiences and currently from 2022 he working as assistant manager from Ola Electric Technologies Private Limited, Bangalore. And with this few introduction, I give away the session to today's resource speaker, Dr. K. Karthik. Sir, we welcome you and the session is yours.
Yeah. Good evening, one and all present here. And I would like to thank the organizing committee to give the wonderful opportunity to deliver my ideas. And it is very broad introduction about me. So thanks all. And today's our topic is the future of an electric vehicle. So why we are moving to an electric vehicle, that we will see in the upcoming slides. And first of all, what is the advantages of electric vehicle? So in the present scenario, if you see that fuel price is day by day increasing, and as well as by using these fuels, fossil fuels, we are facing a lot many things like this environmental hazards, and because of that, this emission also it is increasing. So for that, to overcome these kind of issues, we are in the position to move towards the electric vehicle. So these are my index, what we are going to cover the topic. So first of all, we are going to see what is the electric vehicle and how it will affect the in EV world, and what is the history, how it has come and how it has developed, and what is the air quality in Indian cities and carbon emission and so on so on. So first of all, what is electric vehicle? So it is nothing but it is having an electric motor instead of any fuel or any petrol tank, as well as any combustion engine it won't have. But here, what we need to do is just we need to charge it. That's it. That electric vehicle, it seems to be a possible replacement for the current generation, because there is no such kind of environmental hazard will be caused because of this electric vehicle. So it is having a lot of, just right. So it is having the lot of positive sign. First one is, your internet is very slow. Oh yeah. So first one is it is inspired by the road going automobility powered by electricity. so no need to fill the any fuel, and it is one of an electric motor or more using batteries. We are having the battery pack in that electric vehicle, so it can able to produce the current automatically when you are plugging in into the charging. So it is having the instant torque. So when it is riding, you won't get a much noise to compare to the electric or any uh, compared to diesel or petrol vehicle. So it is very much easy, fast, fun, efficient, and maintenance is very much easy compared to other non-electric vehicle. So first thing we need to see what is the ecosystem of electric vehicle. If you consider the key system players, first one is consumer. Without consumer, we can't do anything with the EV vehicle. And then data flow, finance, insurance, tech R&D, climate change, and policy. And second point of thing, we need to consider the major trends. What is the major trends in EVs? First one is vehicle information. We should know what is the uh, capacity of that vehicle and how much battery capacity it is having. That kind of knowledge we should know. And then batteries, lithium ion batteries. Lithium ion batteries is nothing but that is the rechargeable batteries which we can able to recharge and reuse it again. Without that, that EV vehicle, it's not possible. And then renewable power, where this renewable power is coming, all depends upon this electricity. So once the electricity is there, then we need to do the smart grid management and grid storage, building vehicle, and so as possible. So with this, we need to consider the electricity and that money consumable and that charging station also available. So where the that history of electric vehicle is comes. So in the 1837, the first electric vehicle introduced by Aberdeen from the Scotland and through inventor Robin Davidson. And later 1841, he built a bigger electric car train like this. Sorry, this one. After that, 1884, almost more than 40 years, the Thomas Parker is created the manufacturing electric automobile in London. So this is a in 1884. This is an electric vehicle, and later, what 1890, the first electric car was introduced in Iowa, USA by William Morrison. The car is little more simplified than this kind of electric vehicle. So this six-seater has stopped, and it is having the highest speed of 14 meter per hour. So we can able to move very slowly only. But if you see in the current scenario, that electric vehicle we can able to run up to 120 kilometer per hour. Maximum speed I am talking about. But in the olden days, this is the maximum speed. So how long time it will reach? It will take the time to reach our destination. It is very pathetic. So and then this is another improvement of electric vehicle. So this non-rechargeable batteries 1830s we are using, and then from this rechargeable batteries is found in 1859. And then the lot many developments is happening to develop the electric vehicle by improving the battery capacity. So finally, the lithium-ion battery is used in since 1990s. The Sony was the first inventor who discovered this rechargeable battery. After that, only the lot many improvement we are facing in the electric vehicle. So why we are moving into the EVs means the number one consideration is this air pollution. So by using these fossil fuels, what will happen? The emission of CO2 and all the gases is causing the air pollution. So according to the green space, it is the research. So they were checking the air quality in India. Almost they have taken like Delhi, Mumbai, Bangalore, Hyderabad, Chennai, like Lucknow. So to compare to other in Indian countries, Indian states, the Delhi is having the more polluted, almost, if you see the estimated death rate in because of that pollution, the Delhi is the number one pollution place. So out of the most 30 populated cities, more than 22 uh, states covered in India are around 41 percentage NOx emission. It is nothing but Delhi. We are due to high vehicle use in 2022. We are getting 41 percentage of emission. Also per month, how many percentage we are got in Delhi? That is 23%. So in this data is up to 2020. We didn't get the updated data. It's not moving. Yeah. So to overcome that problem, so if you see this PPT, so the carbon emission we can able to calculate by using the different kind of vehicles. So up to 15 percentage the CO2 emission is because of the advanced internal combustion. So we are using the so many trucks, and flights, so many things. It is emitting more number of CO2. So 10 to 30% it is due to the natural gases and the biofuels. If you take the hybrid fuel plus electric vehicle, we can able to see the 30 to 40% of CO2 emission reduction. If you see the fully electric vehicle, it is 50 to 100 percentage. We can reduce the potential. If it is the hydrogen storage vehicles, that's the same thing. The fully electric vehicle as well as hydrogen storage vehicles, we can able to reduce the CO2 emission up to 50 to 100 percentage. And number of deaths due to the pollution. So yeah. So if it is a thing all over the world, so number of deaths due to the pollution is much higher in India. So if you see, the Philippines is having 0.09%, and if you take Brazil and Congo, it is having 0.1. So in US, it is having only 0.15%. If you consider in India, it is 2.51% per year. So it is very huge. So why means because we are using the petrol diesel vehicle, and due to that pollution, this much death is happening in India. So to compare to other countries, we are seeing the topmost 10 countries. Among them, India is the topmost death rate. So how we can control that emission, and what is the average lifetime of the emission? So these many things, if you see the all the petrol diesel vehicles and so many factories and lot many things, because of this the emission is increased. And if you do the clean electricity and electricity from coal, oil, gas, that also will cause the CO2 emission. So if you see this graph, the lifetime greenhouse emission as well as whatever the consumer using the types of vehicles. If you consider the conventional petrol vehicle, so emission is up to 25%. So if you see the hybrid vehicles, so you can see the 20%. It is almost 5% lesser than this conventional petrol bike. If you consider the battery vehicle, almost 15%. So this is the average lifetime emission of the CO2 emission. So that is the only reason we need to move into the EV vehicles. So what is the major factor that attracts to in the AV world? So one should know the some basic parameters. So which is reliability and feasibilities. So if we are moving into the any new system or any if you want to compare to any other thing, first we need to think the reliability, whether it will reliable or not, and then affordability. So affordability wise, we are comparing into the price. So what is the conventional vehicle as well as this EV vehicle, and how it is growing infrastructure. So growing infrastructure in the sense, if you are using conventional cars, so we can able to see the fuel station every 1 kilometer or maximum 5 kilometers. But if you are considering the EV vehicle, nowadays only we are growing slowly. So that kind of infrastructure facilities we need to check. Also service center and all. So another main thing is public health. By using this electric vehicle, what is the emission it will emit, and how kind of impact it will create into the public. So that kind of thing we need to consider. And a comparison between electric and petrol vehicle. So it is the main parameter why we need to move into the EVs. So if you see the model, what is the model? X showroom price, HSS. HSS means nothing but home storage system as well as large scale storage. And this is a petrol vehicle. So if you are using the X showroom price, the lithium ion batteries car is 87,790 rupees. If you consider a lead acid battery, 35,490. So the petrol price it will come around 60,849. So if you are considering the CO2 reduction by EVs in last 5 years, so it is very much less. If you see the lithium ion batteries, it is 1.9 percentage only. If you are taking lead acid or some other vehicles, so it is causing almost to 2 percentage. So this kind of thing we need to check. So battery cost wise also, for 5 years you no need to worry about this battery, and for lead acid every 5 years you want to replace it, and every years it will costing this much price. But these EV vehicles, you no need to worry about that cost wise. So once the discharge is over in your battery, you can recharge it again. So for this EV vehicle, the government, every government is having so many policies, and they are initiated so some rules and regulation, and some subsidy also they are giving. So that kind of things we are going to see in the upcoming slides. So if you see the electric vehicle policy roadmap in India, in 2010, the Indian government announced the strategy to reward the OEMs with a budget of almost 950 billion. So they are initiated in 2010 only. Afterwards, in the 2012, so the incentive program was scrapped, resulting in 70% of reduction in electric vehicles. So from 2010 to 2012, they have achieved the 70% reduction. In 2013, the Indian government has established the like NEMMP. It is nothing but a National Electric Mobility Mission Plan. So 2020. So within that 2020, they are having some vision and mission. They have to complete within that year. So in 2015, they have introduced the FAM1 scheme. So what it is means they are launching 1st April. This is a tentative date. So within that date they have to complete this mission FAME, that FAM1 scheme they have to completed. The budget is around 5.29 billion. Okay. So in FAM2, so they are starting from 1 April, 1st April 2019. So here they are able to achieve uh, around almost 100 billion. So from here they have reduced the 5% of taxes. If anyone will buy the electric vehicle, they will give the 5% of tax reduction. So some states still now we are having the some toll free also. Whenever you are using EV vehicles, either it is fully toll free or otherwise half of the less to compare to other vehicle. Also, there is so many policies available. For example, Delhi, they have announced too many schemes to the people. In 2020 policy, what it is said uh, by 24, the goal is 25% of new car registration to be electric. So by the next year, it is almost only one month is left. So their target is by the next year we have to register new cars almost 25 percentage. And then the monetary buying incentive they are giving 5,000 per kilowatt hour. So this kilowatt hour means what it is means, if you are maintaining your car, the battery is having some limitation. If you are riding very fast, you're like the same like a petrol and diesel vehicles. If you are maintaining your vehicle a smooth and good manner, there you can able to save the kilowatt hour. This kilowatt hour is nothing but your battery capacity. So it is for 2 watt. If you save how many watt you are saving, for 1 kilowatt they are giving 5,000. So this kind of incentive is there. Like Maharashtra electric vehicle, they are also giving some target of increasing EV vehicle in Maharashtra almost 5 lakhs throughout the course in the 5-year policy period. And they are giving the some investment USD 3.4 billion for the manufacturing of EV vehicles. Suppose anyone want to try or anyone want to start this EV market, they are giving the some government fund also. If you see the UP government, they are also giving the rolling out mission. Rolling out mission means they are introducing that EV component across all the segment of 2024. So all the electric vehicle scheme, the target is next year. So by that next year, they are going almost 1,000 electric buses developed by the state by 2030. It will take some other time. So nowadays people are considering only two-wheeler and four-wheeler, but these electric buses it will take some time. But in here in Karnataka, the Karnataka government already running the EV buses, so it is very much affordable for people also, and very much nice pollution control, and a lot many advantages are there. So here also our Tamil Nadu government vehicle policy 2010. So make Tamil Nadu manufacturing of EV and clearly equipment. So that's what in our Vola also in Tamil Nadu, my area, that is called Pochampalli. Yeah, there we are having the Ola Pressure Factory. They are almost produced more than 2 lakhs electric vehicle in the last year. So now we are going to build the gigafactory. It will functioning in the next year. So there we can able to we are planning to produce 2 gigawatt hour per kg. So that will happen. So for that, a lot of schemes are available in the government. Where they are giving a lot many things and a lot of investment is available. So they are encouraging the investment in electric mobility. If you want to do the electric vehicle business or any factory, they are giving almost a lot of funds to the whatever the consumers, and then 100 percentage from registration fee and 50% exemption from the motor vehicle tax. As I said already, they are giving for registration is free for a EV vehicle, and almost 50% exemption from the we need to pay the some tax now. From there, 50% tax exemption is available, and 100% exemption from the electricity duty for e-charging station. Wherever you are charging, there you can get some offer. So like that, Gujarat EV vehicle policy is there, and Karnataka. In Karnataka, they are encouraging the people almost 100% of their four wheelers. Already told they are running buses, autos, and cabs. A lot many cabs we can able to see in Bangalore. So 100 electric buses, yeah, that I already told. 100 electric buses will be introduced to local public transport bus fields. They already introduced it, and they are aiming to set up 112 EV charging station in Bangalore. So this is a slowly growing country. So now only they are initiative for the electric vehicle movement. So in future we will vanish this petrol and diesel vehicles. So by 2030 or 2040 in India, we can able to see in every house we can able to see the electric vehicles. So, what is the electric vehicle market? Which are the players playing major role? So, if you see the 2019 market size, there is around 1027 billion in market range. So, we need to increase it. The market growth in 2029 to 2025 almost 54.2%. In 2025 market, we are expecting around 13 billion thousand. So that much demand will be there for electric vehicle. So in India, the electric vehicle market valued around $5 billion into 2020. So we are expecting it will grow up to 47 billion by 2026. Okay, it is 44% more than the this growth rate. Okay, so what else? So also in a Indian EV market, it is infancy. Infancy in the sense, as I said already, now only we are starting slowly. So it needs due to several government initiative and policies. So it will increase day by day slowly, and then this carbon footprint as well as e-commerce business such as Amazon are starting effort to deploy e-mobility. So here also the e-scooters are available. So we need to download one app. Whenever you are scanning in that QR code, it will automatically switch on. So wherever you want to go within that circle, you can take it that e-bicycle like it is Yulu bikes. So it is very much affordable. Those who are waiting for buses and autos, it is very difficult, and you can use it. Uh, as I said, the key players in India, the two wheelers. From the two wheeler side, as Agenda Manufacturing, Ampere, Avon Cycle, BPG, BSA, Chris Motors, Eco Electric, and Hero Motorcorp, and Honda. these many things are there, and U-bikes and Ola. These are the major players in India for the two-wheelers. If you consider the three-wheelers like auto, taxi, this kind of thing, Bajaj Auto, Electrotherm, Mahindra and Mahindra. If you consider the four-wheelers, so Mahindra and Mahindra is playing everywhere in the EV vehicles and buses. It is at present Walmart, Engineering and Volvo. This kind of key players are there, and HDVS. Here also Walmart and Engineering and Volvo, they are playing the major role. So if you consider the electric vehicle unit cell, so by year by two-wheeler and four-wheeler, you can see in the financial year 2015 to 16, that time only we started, and it is around 20,000 for the two-wheeler and 2,000 for the four-wheeler. And then every year it is drastically increasing, and now up to financial year 2019 to 20, it is almost reached 1,52,000 for the two wheelers, and almost 3,400 four wheelers have been sold. So that Kerala plans have 1 million electric vehicle on the road by 2022 and 6,000 electric buses in the service by 2025. So Kerala is the main city who is developing the EV vehicles. And Telangana also aims to gain the EV sales. They are targeting 2025 to achieve 80% of two and 70% of three wheelers. And commercial cars 40%, buses 30%, private cars 15% should be electrification. When by 2025, we are expecting, but we will wait and see. So these are the EVs sold by 2023. So if you consider the four wheelers, around 16,000, 17,000 four wheelers have been sold, and two wheelers around 2,31,357. If you consider the three wheelers like auto, 1,77,000 and 874 three wheelers have been sold in 2023 alone. So these are the electric motors and key trends. What is the electric motor price, and what is the batteries, how much it cost, and power electronics and charging station. This many things is playing for the EV world. So this is the key trend. So one third of EV motor market will show up need to EV business in India by 2025. So if you consider the EV vehicles, we should consider the electric vehicle motor also. Without motor, this vehicle won't be run. And more than 67% will be the passenger car segment share in battery market 2025. And around 16 billion kilowatt. So the power of the capacity, how much capacity we need for run the electric vehicles. So it is around 15.6 million kilowatt hour will be the total demand for lithium ion battery pack in 2025. So the big thing is the charging station. So around 61% will be need for the 2-watt vehicle segment share in the power electric market in 2025. So these are the major for the EVs component industry growth in financial year 2025. So where we are standing. So if you consider the EV market in the world, so Norway is the number one country. They are selling around 13% all over the world. So if you see the Iceland, it is 4.47. If you consider even China, the all the product is coming from China, but they are unable to make the EV world. But they are also in the topmost in country. So 1.6 percentage they are selling. But if you consider in India, we are in the 0.07, it is too less. But after some time we will also grow. Just one. Yeah. So as of 2023, the world had 15 million electric cars. Almost we are expecting the 40% jump over 2022 as well as 2023, and we are in the last position in this chart. So we are also slowly growing. Definitely we will reach at least some 2 3 place up in the upcoming years. So key players of the EV market again. So these are the main key players in the EV world, like Maruti Suzuki, Exide, Ashok Leyland, Mahindra, and Tata Motors, of course, our Ola. So we are all the key players. And if you consider 10 most popular brands, electric cars, the first one is Tesla. So wherever you go, you can hear about the Tesla. So Tesla is basically from US company. So they are the number one in the EV vehicles. So in Tesla model Hardy car, so it is around 1,19,000 with the values of in dollar. If you see the car price, and this is how much EV vehicles they are sold by all the brands. And next one is Jaguar, Mercedes-Benz, BMW, Nissan, Kia, Hyundai. All other companies also playing the major role. So next thing we need to consider the charging point. So electrical dilemma. So what do you need for this electric vehicle infrastructure advice? This is the main thing. So all the times, if you are riding the commercial some other petrol diesel vehicle, if your fuel is empty, so you can go nearest place and you need to fill. So if you are riding your car in between your charge is down, what you will do? You can't do anything. So for that we need to such a proper charging station. So that is the biggest problem now. So for that, more than 30% of electric vehicle road by deliver electricity by 2030. So we are depending upon this electricity also. Almost 16 crore unit increase in the power demand. So if everyone is turned into the electric vehicle, of course, we are facing the electricity demand. So now also we are facing lot many things in the electricity. So if you consider here, almost 1 lakh 38,000 and crore unit we need to generate all the EV bills. So almost the core unit demand will happen, and core cell and the unit is shortfall. So this kind of thing we need to rectify, and we need to uh, overcome actually. So then only the EV vehicle will be successful in the Indian market. So if you see the electricity demand by EVs in 2030, so if you are using the car, you're, you will be facing almost 26% of shortfall in electricity. If taxi is means only 10%. If you are considering buses, it needs a lot of energy, so it will take place 28. And 2 watt hour. two-wheelers and three-wheelers. Two-wheelers will take very less only. So this color is about a mileage, and this one is 100 terawatt hour. So how much terawatt hour it need by 2030? So as I said already, the electricity demand will be there as India prepares to achieve 30% market penetration into the electric cars by 2030. So definitely we will going to face the electricity problem that how the Indian government will taking care that we will come and see. And it will give the 80% of country population uses electric vehicle in India. So we are expecting to uh, requirement of the electricity consumption is around 100 terawatt hour. It is very much huge, about 5% of total electricity by 2030. And according to the NITI Aayog's energy policy, they have done some study, and finally they are releasing this data about the Indians' energy consumption would be double by 2040. Of course, if everyone is using the electric vehicle, definitely that the electricity demand as well as the needs will be increasing. So we need to overcome this kind of problem. That is our next headache. So at the last, these are the conclusion. These are the conclusion. Almost we are gone through about the EV industry and what is the outcome and what is the expected performance will expect from the electric vehicle to compare to the conventional cars or any bikes. So uh, it didn't quite deliver on all fronts, and these results having the mixed reaction in the industry. In the industry point of view, so lot many government policies and so many funded will be there, and if any students are buying the electric vehicle, the government is giving, especially for a women's candidate, they are giving so many subsidies. So it will differ depends upon the every states. So it is all depends upon the governments. Okay. So we are going the pace of any business vehicle in more than 15 to 20 years old by 2025. So in all the Indian government, they are targeting by 2024 or 2025, almost 50% of electric vehicle should be there in our home. So that's it. Thank you for your wonderful passion.
Thank you, sir.
If any queries, you can ask.
Dear participants, if you have any queries related to EV vehicles and batteries, you can post your queries. Unmute yourself and you can raise your doubts.
Hi, sir.
Yeah,
Hi, sir. I am Surender.
yeah.
Sir, most of the EV vehicles, the cost will be high, but uh, the people side awareness up to not coming, sir. Main reason, battery issues and vehicle service provider side issues like that coming. What are the problems and rectified, sir?
Actually, in the EV market, we are facing the problem only because of that battery charging.
Ah,
So,
yes, sir.
so normal people don't know about the battery chemistry. So what are
Yes, sir.
if we are providing any EV vehicle, there is a certain limit. So this much charging we need to do. This much speed only you have to maintain. Like that, so many SO is there. So if you are not obeying that kind of limitation, and definitely we are facing the problem, because whenever you are riding a vehicle, EV vehicle, the battery normally used to get heat. That heat energy, if you keep on going for long distance, what will happen that the battery pack, we used to call battery pack, that battery pack will be expand. During the expand, what will happen inside the battery, we are having the lithium metal. That lithium metal, what will happen? It will touch in the anode and cathode. It will chance of getting fire. Because of that only this kind of accident is happening. So
Suppose the EV vehicle long drive for any Kodaikanal hill station or Ooty hill station, if it is not possible, and the people are how can to buy a EV vehicle, sir?
but you can travel to the lowest temperature region. I am telling about the normal. Here in Bangalore, it is okay. If you consider like Chennai and this hot place, so normally that room temperature is almost 20, 23, 20, 25, sorry, 30 to 33 degrees centigrade. In that kind of scenario, you should not drive this vehicle for long travel. So in that lower temperature area, you can drive no problem. I am talking about generally. So all the people won't drive in the hill station, right? Most of the
Yes, sir.
people will ride in the normal road and all. So this is a precaution we need to take care. Hi.
So I have a question.
Yeah.
So in your presentation, you have
Mm.
mentioned a lot more players, major players
Yeah.
in
Yeah.
electric vehicle manufacturing as well as in marketing.
Yeah.
Even though we have more number of vehicles, EV are coming up in the recent days,
Mm.
still the Tesla maintains its uniqueness.
Yeah.
What way or what is the unique about Tesla?
Actually, in the EV vehicle world, we need to consider the infrastructure facilities. Okay, so the Tesla is having a huge factory, like a gigafactory. So they are having all the facilities, and whatever is failure is happening, they are rectifying within a day. But if you consider in India, we don't have such kind of facilities. We are expecting some other facilities from. We are actually depending upon some other country like China and this some other countries. So that is a major problem. We are unable to achieve, and almost the Tesla they are started long back, but in India concern we are starting now only. So we are slowly developing. So in future we will also in that position. But Tesla, that is the brand. In every phone we are using a lot many phones, but still Apple is the number one. Why? Because the feasibilities and that performance and all like that only. So many key features are available, but Tesla is number one because of that infrastructure facilities and that kind of thing.
How the battery is different from other company
Uh,
vehicles and the Tesla?
One more thing I want to tell you that battery and all they are manufacturing their own. So what we are doing in Indian market, we are importing the batteries from some other countries like China and Korea. Mainly we are getting batteries from Korea. That is a problem. That's what that battery usage is coming. So there the temperature is different. Here our Indian country temperature is different from some other states. So that is also main problem. In Tesla they are manufacturing the own batteries. That own batteries they are using for their EV vehicles. That is a main advantages for them. So that's what we are also building up our gigafactory, so which can be able to produce the large whatever per kg batteries, so that batteries we can use for our vehicles. So if you are manufacturing your own batteries, that is very much useful for to deliver the better EVs. I hope my answer will be helpful for you.
Yeah, thank you.
Mm.
So, dear participants, if you have any questions, you can unmute yourself and you can raise your doubts.
Yeah, sure. Is there any other question?
So I hope. So we will post your mail, sir. In case any doubts, they will contact you through email.
Sure, always.
And thank you, sir.
Yes, thank
And I
you.
would like to express my heartfelt appreciation for your presentation at this FDP and your insights, your statistics and data about the future of electric vehicle was informative and meaningful. So on behalf of Department of Mechanical Engineering, Swarnandhra College of Engineering Technology, I thank you for this wonderful presentation and for your presence in this FDP. And I hope the participants will get benefit out of your presentation and the information that you have shared. Thank you, sir. Thank you very much.
Thank you once again. Welcome. Bye.
Thank you. So, dear participants, the second session will start in another 5 minutes. So you can have a break for 5 minutes and you can
அவங்க தப்பிச்சிருவாங்க அப்படிங்கிறது
Sir, good evening, sir. Sir, please unmute yourself.
Sir, good evening, sir. Am I audible?
Yes, sir, you are audible.
Okay, sir.
Let's start, sir.
Yeah, we can start, sir.
So, good evening once again, and I welcome you all for the second session. And I would like to welcome our today's second session resource speaker, Dr.A.Manivannan, Associate Professor from Sri Sai Ram Engineering College, Chennai. Sir has completed his post-graduation in engineering design from Anna University during the year 2007 and completed his post PhD from Anna University under the topic Metal Matrix Composites for Thermal Applications. And Sir is also having industry as well as academic experiences, overall 15 plus academic plus research experiences, and has published 4 patents till date, and having vast commendable experience in the field of metal matrix composites. So with this few introduction, let me invite today's second session speaker, Dr. Manivannan, sir. Sir, we welcome you, and the session is yours.
Thank you, sir. Thank you, sir. Shall I start?
Yes, sir.
Good evening, everyone. Am I
Sir,
audible, sir?
Share your screen, sir.
Yeah, I'll share my screen. Good evening, everyone. Sir, is it okay right now?
Yes, sir. But make it, yeah, fine, sir.
Hello, everyone. Good evening. This is Manivannan from Sai Ram Engineering College. And I'm going to talk about today about additive manufacturing for innovative design and production. The arriving on this title itself quite tricky. How come additive manufacturing we all heard about? Very commonly, it is a layer by layer manufacturing process. And there is also one more thing, that is subtractive manufacturing also. So how come innovative design and production it is going to help in the context of additive manufacturing? This is what I'm going to talk about. Okay. These are all the contents. What is additive manufacturing? Its applications, and how do we contentfully get into additive manufacturing through thinking process. For any technological innovation through thinking process. Next, the state of art of refining it. As you all very commonly know, the necessity is the mother of invention. And that is how engineering arises. It is very common, and being a faculty members, you all know about it. Necessity is the mother of invention. So that is a key word that boomed. That is a keynote that boomed engineering evolution into a QR code culture for everywhere. Next, what does the future hold under additive manufacturing? Any technological innovation, that is the pros and cons that we are going to deal about. Next, this is the definition of additive manufacturing. It is as per the ASTM standard. Okay. The additive manufacturing refers to a process by which a digital 3D design data is used to build up a component in layers by depositing materials. That is what additive manufacturing terms actually. In a broader perspective, what you see is, I think you all can view my mouse. Anyone can be interactive, please, sir. Hello, sir.
Yes, sir.
Okay. What you see is what you build. Actually, what you see is what you build. The miniature parts, components, what we are making, no. The miniature components and all, it comes under the category of additive manufacturing. In a narrow down way, people used to call it as 3D printing. Okay. That that is a difference between rapid prototyping and additive manufacturing. What is the difference? The rapid prototyping, it is a miniature creation of some other materials or some other stone age. Suppose if we go for a temple, 1,000 years old temple, or a monument, Qutub Minar monument, that prototype what we make in the other material using thermoset materials or thermoplastic materials, that is termed as a rapid prototype. And it is also in the plastic industry, rapid prototyping is very demanding due to its intricate components manufacturing. The additive manufacturing, it turns into the metal matrix formation, metal matrix combination of formation for the composites manufacture. This is additive manufacture chart actually. 3D CAD model. Everyone are aware about it. Some may aware about it, about the slicing process. You have to 3D model a component, then it has to be sliced so that the slicing can be the layer-wise assembly and it can be into a final complete part. This is how it goes on. See, this is the way, the slicing, how it is happening and how the miniature is created. The component, it is modeled. This one is 3D draft model. Actually, this one is a solid model. Afterwards, how come the additive manufacturing is happening a layer by layer? This pictorial refers. Next. These are all some of the examples of 3D printing or additive manufacturing, whatever way we can call. 3D printing, it caused the machines of a rapid prototyping like utensils, wire utensils, and ready-made household articles, what and all manufactured. See, the wire briefs and the plastic briefs, our buckets, everything are 3D printed nowadays in a miniature sizes. And whereas we go for the production components of mass components with the precise quality, we shall go with the additive manufacturing. The best, actually, the best process in additive manufacturing, we can go with this SLM dead, and we shall look into it. The production components involved, the machines manufacturing costs are around more than 50 lakhs. The production components. What are all the components they manufacture? These are all the components it can be manufactured. Some of the aerospace industry applications and some of the medical applications, even the hip bone transplantation and also elbow transplantation. Some get injured over by accidents. Their hand elbows can be replaced by the titanium material of, and most importantly, the titanium, a particular alloy, is deeply into research for this additive manufacturing process. Later on, we will see. See, as I said, the bones can be replaced using your natural, organic, as well as the metal combined. So it will give endurance, higher endurance. So in some cases, the skull, even the major accidents with the skulls are even get affected. So this is a component of it is for a turbine component. Next we shall, so this is for medical applications. It is similar like a robot. See, it's how the things are functioning. Next, the additive manufactured bicycle and the additive manufactured components of mechanical components of varying. See, it can be of two process, additive manufacturing and also subtractive manufacturing. Based on the part complexity, these are all the parameters which decides the component and the customer requirement and the end user friendliness decides the type of manufacturing process, whether it has to be additive or subtractive manufacturing process. The part complexity decides it, and the material we are utilizing it for, the manufacturing process and the cost involved in it, the part quantity, number of part quantities going for the assembly, next to the speed of the manufacturing process required, the time which we need to give it to the customer. See, this is the best example of the additive as well as subtractive manufacturing. See, the additive manufacturing, the cup is manufactured by means of additive manufacturing, whereas this engraved, this thing, what you call, the internal features cannot be machined without a tool radius. So this and all decides the design for the criticality about the additive manufacturing process. The undercut here cannot be performed without more than 3-axis machine. This, the every detail, the cavity, the here cavity, no, that is formed by means of even though it is formed by means of additive manufacturing process. To have a precise accuracy, this part and this part have to be on the subtractive manufacturing process. So that is where we can get the most precise accuracy of what we require. This figure features that represent problems using in the CNC machining. So our topic for it, it deprives over the design. So the future slides will be based on the innovative design practice over the additive manufacturing process. The source of this document is from the Gibson, that is additive manufacturing. I will share you the what and all the references I had for this session. This is the ultimate process of getting 3D model into the usable product, that is CAD. Next, STL converter. After STL converter, the file transfer to the machine. Then the machine setup for the CNC machines. Next, it is built up and the removal process. Then next, post processing of the component. In the build up process and the removal process, it is CNC process. Next, the application where we are utilizing the product. It's a generic additive manufacturing process actually. So, see, as I said earlier, the additive manufacturing for innovative design and production, I have coined this term for this session based on a video which I would like to share. Sir, King sir,
Yes, sir.
can I share that video?
Yes, sir, you can share.
Okay. Sir, is it audible to you all?
Your voice is not coming. You can see the movie.
This you can see in our brochure actually. I have shared with the coordinator before deciding the title. Yes, sir. I have taken this video from MIT actually, MIT website, and I'll share the link in the chat box after the session, and you all can have. So no was someone else. Now is it audible, sir?
Yes, sir. Yes.
Yes, sir. Okay. One moment, sir. I hope now my screen is visible, sir.
Yes, sir. Vishnu.
Sir, this video made me to arrive on this title actually. The additive manufacturing for innovative design and production. 1 minute. Sir. Why? Because no. See, the innovative design brings a fascinating and possible outcome of the better best what we can do. So the better best can be achieved by the 13 points, which are like a Bible for additive manufacturing. That is design freedom and rapid prototyping. These are all the key points. And I'm going to talk about this. This first 2 points, design freedom. Additive manufacturing lets designers construct sophisticated form that are impossible to make using standard methods. Freedom to design can lead to more inventive and efficient products. RPT, it offers affordable prototyping and traditional prototyping, and also it makes less time and less money. The design iteration can be made number of times. That itself is possible of a creative, innovative design we can arrive it on. Next one is the customization. We can customize to our own specification whatever we need. The customization. When we go for that word customization, you all arrive. You can compare it with your mobile phone. See, the n number of VHS we are having with our phone. This was not for 30 years before. That is before 5 years or before 10 years. We didn't have that much specification of customized whatever we are having. Now we are operating bank over phone. Before 10 years, it was not possible. Literally, it was not possible in India. Over phone, before 10 years, it was not possible. Now the customization changed all the bank process into the mobile. So the innovative design makes everything will fall on the place. The technology permits bulk customization of the products to meet the customer wants. This is most importantly in the healthcare where tailored implants are most preferred. Okay, and less trash. Whatever we do, the trash components should be very less. Whether we make any music or whatever we do, we don't want to have much of trash components. So the subtractive manufacturing produces a lot of trash. That itself creates a lot of mental agony to the creators. So instead of going with the subtractive manufacturing, we shall go with the additive manufacturing that employs what is needed and it decreases the waste and it is also an environmental friendly. The supply chain optimization can be a possible way to reduce a cost reduction, to make a cost reduced component to the market, where the company can get the maximum amount of profit and they can grow on their business the way how they predicted upon. Next one is for low volume or on demand production, the additive manufacturing can be cheaper than traditional manufacturing process. Yeah, traditional manufacturing procedures or processes. Next, the topology optimization. The design software, it reduces the effort of the trial and error basis components. So we can monitor over the system and we can analyze over the system based on the analyzing softwares. Then we shall arrive on the optimization process. That the topology optimization helps. And it also produces the more lighter component, which means the density, reduced density with high endurance and also with the stiffness component or more. And the material saving also more. That gives the profit component higher for the company and also the performance of the product is higher. The additive manufacturing uses metals, the materials and all metals, polymers, ceramics, and also composites. Nowadays, metal additive manufacturing is also in the boom. You can also refer to an NPTEL course that is a metal additive manufacturing by Professor J. Ram Kumar, IIT Kanpur professor. And it is a very good course actually. The persons who are very keen on the process of additive manufacturing and the persons who are involving on the initial phase of the research using the additive manufacturing can get into that course and gain much of the knowledge. And that would fetch you more knowledge. My personal recommendation. Next one is the design for functionality. So any component, whether it is of a laptop or a mobile phone, we work it for the functionality. The end of the day, if it is not functional, it is an obsolete component. So to go with it, the additive manufacturing favors the functional design far beyond the restrictions. This allows the component consolidation and simplification and enhancing the performance of the products. The additive manufacturing does not also involve in much of the costly molds or the costly tooling. It refers to the minimal or much of capital expense only, great capital expense. Rather than the rate of maintenance, you would traditional machining process, traditional machines and all, you have to invest a lot for the maintenance in case of the machining processes, everything. The innovative geometries cannot also be applicable to the additive manufacturing process, whereas the traditional machining process demands high time for the manufacturing the component. The additive manufacturing also allows more of the aerospace components, automotive components to explore lightweight and high strength, the honeycomb structure even. In the future slide, I will show you the honeycomb structure. In the video also, we had seen the honeycomb structure. That is under critical structure. That is made possible with the innovative design component of additive manufacturing that leads to the possible production. Okay. Next, repair and maintenance. This is where the huge amount of the money the mechanical industry is spending on. The on-site repairs and maintenance using additive manufacturing reduce downtime and costs for enterprises using vital machinery and equipment. So, yeah, and the traditional bound, whatever, and the computer numerical control machines also, CNC machines also, the FMS machines also, that is flexible manufacturing system also. I have a vast experience over FMS also. So the repair and maintenance cost also, it demands huge in your profit margin. So to accommodate with it, the people are moving beyond the capital investment right now nowadays. The manufacturing chains, whatever GE, everything, Boeing, they are into the massive investment over the additive manufacturing. The slides are there to evidence it actually. Next, the bioprinting. As it is very evident, the medical additive manufacturing, it would create tissues for transplantation and organs. Organs like bone ligament fractures, and also for the research, the bioprinting, n number of researchers are going on, and the medication testing. I would suggest to young minds to concentrate more on the bioprinting of additive manufacturing. That would be the brilliant boom for our mechanical industry as well as the interdisciplinary biomedical industry. Okay, this is the any technology, there will be an exaggeration. When it is triggered on the technology trigger, it started here. I hope everyone can view this aroma. Okay, the technology trigger started here, and the visibility force in it attained peak. The inflation happens. Where the inflation happened? Through the disillusionment. Where the expectation didn't meet the demands. There the inflation happens. Then the additive manufacturing slope of enlightenment happened. What are all the pros and cons? The investors realized and they get into the plateau of productivity, like the consistent way, like it's booming like this way. The time and visibility chart has shown how the exaggeration over that this technology has been arrived upon. This I have collected from an web source actually. The key points over the additive manufacturing design components. The needed to design for additive manufacturing is tremendous. Why? Because all are intricate components. We are going with additive manufacturing means we are going with the highly critical geometry. First case. Next, the focus on the precision, accuracy, and also third case, the time frame, and also last one, the efficiency. The reduced weight, the scrap, and the cost, and also the combined components. At most, if we follow all these parameters, the cost can be cut down. The mounting holes and brackets built into the part. Okay. In the part itself, the holes and brackets, whereas in the conventional machining process, we cannot go with this cushion of getting the manufacturing done, actually. The process, actually. After the design, the process, it it's not self-supporting. It may require supports. The process requires supports. What type of supports? The investment of a machine. Next, and also raw material supply, and also the like a FMS. It needs a computer. It needs to be sliced, and then it needs to be transformed, attached to a platform, and removed post build. Next, it may require post processing to achieve finish required. For the high precision quality, what do you call surface finish, that needs a post processing of every component. This is the example of a gun, a two pistol gun. A two pistol gun. Okay, this is where how the additive and manufacturing and the subtractive it is happening. This part, the left side top one, no, it is showing the additive component. Okay, this right side top one, it shows subtractive. Left side bottom, it shows again the geometrical criticality, geometrical intricacy of the component. And the last one, it shows the extrude property of the outer case of the component. So here comes our component. The final part, it is a mass reduced to 30% of its original. And most in case, the reverse engineering of components are most preferably done with additive manufacturing. Why? Because means it is a, first of all, it's a reverse engineering process. Second one, it's cost efficient. Third one, the intricacy of the component, the geometrical variation can be done very easily due to the draft 3D modeling, and it can be converted into solid modeling. The smooth flowing pathways can be attained. The final part, what are all the benefits? The higher performance. This made manufacturing lead time halved. So as all faculty members, you all know the manufacturing lead time, how it influences the productivity and how it affects the business of a company. Next, this slide I wantedly added for the research perspective. The faculty who are all very keen on the additive manufacturing research, no, the titanium research, this particular alloy, people have explored much. There are n number of research articles over this titanium and nickel also. Marketing field, this and all upcoming on, and cobalt, chrome. This aluminium, nickel, and titanium people have explored much. This state of materials, not only, see, in the previous slide I have shown you the plastics and polymers and ceramics can be additive manufactured, whereas the metal can also be additive manufactured. And I have rightly said, and metal additive manufacturing NPTEL course for you also, which is run by a IIT Kanpur professor. Okay, you can follow it for getting into this type of metal additive manufacturing research. Next is the future, what it holds on. The additive manufacturing, what it holds on. GE have expanded tremendously rather than concentrating on the other manufacturing modes. The additive manufacturing, GE has expanded. Its new LEAP engine will have 9 additive manufacturing parts. It will have over 1,000 individual components for it to make and assemble. Next, the parts already flying in US military aircraft and in orbit in satellites are the additive manufactured components. The other components are in test for future missions in the military aircrafts as well as in the NASA. Next one. The future market. The crucial components already the F1 racing people very crazy about, and the further components and materials are also being tested upon. Why, sir? The endurance limit. The endurance limit of the F1 cars needs to be high. As you all know about that, the frequency of accidents are more in the F1 cars, and starting from the helmet to the component, which is very least concerned about. So it needs to have high endurance limit, as well as the density to should be supportive to the pilot of the car. So he should be very capable to run in the high speed. Then medical application in the future, the optimize the surface structures and all, it needs approval from the FDA. That and all in the research actually. The future markets, what I have made, no, that and all paper components actually, the research paper components based on which the acute tubular cups and hip bones and hip implants and shoulder implants. Majorly people concentrating on hip implants and the elbow, knee implants, transplantations, everything people concentrating. The future materials, what can be? The pure copper can be an 3T building. Actually, the researchers are going on in the 3T building in pure copper in talks with Sun actually. Next, the new material suppliers coming online. Okay. This will be the pure copper. This is also in the research. The potential materials in what would be means the tungsten, niobium, molybdenum, and the copper alloys. This is the summary what we had seen for this session, and based on the additive manufacturing session, these are all the summaries. I can frame it out. New opportunities, that is holes and channels and lightweight optimized structures and multiple parts and built as one components can be the additive manufactured components, and the parts already in use for a critical application, whereas in the see what I'm saying now, it is in the highly demanded application, that is safety applications. Safety application in the sense the aerospace application and the flight and the mission and critical. Even the infantry also, the additive manufactured components are nowadays they are preferring. The materials being developed and supply improved. The new machines allow for more material. The machine research also going on for the additive manufactured components. The machines are no longer have a limitation. That is a technological growth. We had a later on case, we had a 3-jar chuck lathe, 4-jar chuck lathe, and high spindle lathe, and over which we gone into shaping machine and we gone into the milling machine. Then our requirements expands. There is no limitation for a technology bound. No, that is what I had arrived with it on. These are all the references I have made. That is from the Gibson Springer publication, and Muller. That is also a Springer publication, and from an NPTEL course from the Professor Ram Kumar of IIT Kanpur. I have referred from this session. Thank you. Any queries, sir?
So thank you, sir. Participants, if you have any queries, you can post your queries. You can unmute yourself and you can raise your doubts.
Srinivasan, sir.
So,
Yes, you can proceed.
sir, you can unmute yourself and you can raise your doubts.
Process wise is 3D printing, additive manufacturing is same. Yeah, sir. Additive manufacturing in a broader scale. See, manufacturing process we say, and welding is a part of a manufacturing process. No, the similar case. 3D printing is a part of an additive manufacturing process. Yeah, marine applications. There are numerous applications people are working on, sir. Marine applications and all. Numerous application is going on. Gautam, sir. Marine field, in specific, riveted joints, people are going in with. Why? Because no, they cannot replace it with normal fasteners. Nowadays, it is huge costly, and they are going it with the additive manufactured components of riveted joints, and that also a very booming field. See, a type of interactive would be very easier for me to acknowledge how I can gain my feedback from it. How well we can control the structure, internal structure of the materials. Yeah, sir. Very good question from Srinivasan, sir. Sir, we can control the internal structure of the materials to the greater extent. To the greater extent, without affecting the properties of what we are going to tailor upon. Okay. Normally in India, people are going in with additive manufactured components with the very least module of this FMCG components only. Okay. FMCG kind of things only. Whereas for the metal additive manufacturing, you can have a broader spectrum of openings.
Sir, good
Any other?
afternoon.
Yeah.
Hello.
Yeah, sir.
Sir,
Yes,
Yeah,
sir,
sir.
you are
Am I
audible. You can
audible?
raise your doubts.
Am I audible, sir?
sir, good
Yes, sir,
afternoon.
you are audible.
Yes, sir. Yes, sir. Proceed, sir. Proceed, sir.
Hello.
Yes, sir. Yes, sir. I'm hearing you, sir.
Hello.
Yeah, I'm hearing you, sir.
Sir, it's audible. You can raise your doubts.
Sir, can you hear me?
Yeah, I can hear you, Mr.
Hello.
Srinivasan. Mr. Srinivasan, I can hear you.
Sir, I unmuted. Like, hello. Can you
I
hear me,
think
sir?
problem. I think problem with his tower. Tower range couldn't be able to possible to speak out his question. Gautam PhD, a sensible question again. In what way additive manufacturing is better than casting? In casting, we can produce components of intricate. There is no doubt about it. We can go with the metal additive only. That is a metal process only. For polymer and ceramic mixed and all, we can go with additive. Whereas metal, polymer, ceramic additive also, we can go with the additive manufacturing process. This triangular combination you cannot arrive with the casting. Okay. And one more thing, you can in casting you will get minute cracks and blowholes, which leads to the depreciation of the quality of the component in later case. Whereas in the additive manufacturing, there is no such case. Anyone?
Srinivas, sir, you can unmute yourself and you can ask your question.
Gautam, it all depends on how you control the process elements, Gautam. The additive manufacturing, I had worked on the additive manufacturing with the NIT Trichy professor, and I couldn't find such things as much as possible with the casting. Okay, so you have to get into it. Then only you will understand. Jet engine blades need single crystal structure to get better creep strength. Is it possible with additive manufacturing? Jet engine blades need single crystal structure to get better creep strength. These are actually, this is a booming field. This additive manufacturing is a booming field. Right now, in that sense of single crystal structure, what you believe on, I'm not sure about getting into it. The single crystal structure, no, that would be a critical case. What Srinivasan sir is asking, no, I don't think so. Definitely. Additive manufacturing is also used for repair applications. And predominant complexity is also there. Gautam. Hope you understood in right sense. Thank you.
So any other doubts? So if no doubts, sir, we will share your mail ID.
Okay,
That,
sir.
any doubts?
Yeah. You can share my mail ID and I'm there to help you all. And I have few connection related to additive manufacturing also. I'm here to help you. And if any collaborations related to metal matrix composites or polymer composites or testing of composites, manufacturing of composites, I'm having links with IIT Madras people also and NIT Trichy people also. And we are having a bunch of professors at our campus also in Sairam Engineering College, and we would help you in a greater way. Okay, thank you.
So
Thank you, sir.
Thank you. And I would like to express my appreciation for your presentation at this FDP. And it was completely a different perspective of. It will be helping for the young budding researchers also in the perspective of additive manufacturing. So thank you so much for your valuable presence, and your insights on today's topic will be enlightening to all the participants. And on behalf of Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, we take our pleasure in thanking you for your valuable presence in this FDP. Thank you, sir.
Thank you so much, sir. Thank you.
Thank you.
Thank you, sir.
So, dear participants, feedback and attendance live stream chat box. So you can complete and submit your forms, and it will be active for the next 15 minutes. And I would also like to express our appreciation to all the registered participants who are all actively engaged in this knowledge sharing platform. In the 6 days FDP on recent advancements in materials manufacturing and technology. So on behalf of our organizing committee, we express our sincere thankful to each and every one of you to sharing and presenting your valuable time in attending this knowledge sharing platform. And tomorrow we Ravindra Kumar Professor from Lakhireddy Ballireddy College of Engineering, Andhra Pradesh, under the topic Computational Comparison and Experimental Performance on Heat Pipe using Concentrating Solar Parabolic Trough Collector. And second session by Dr. Jogi Krishna, Professor and Head Mechanical Engineering Department, Rice Krishna Sai Prakasam Group of Institutions, Ongole, Andhra Pradesh, under the topic Heat Pipe with Nano PCM for Electronic Cooling Applications. So these were the two resource papers for the tomorrow's session. And tomorrow is the last day of the 6 days FDP. So we expecting your presence and your active participation for the last day also. And submit a test based on the last 5 days session. So based on that and based on your attendance, your certificates will be submitted. So, dear participants, the feedback will be active for the next 5 minutes. And tomorrow's test instructions and any queries related will be shared in your WhatsApp group. If you have any further queries, you can kindly post to my WhatsApp number. Thank you. Happy learning. Tomorrow we'll see.